Good afternoon. My name is Hardik Jain, and I am one of the co-founder and CTO of GXE. Thank you for inviting me to present a new technology that very well complements Wi-Fi. And so let me start with kind of like a brief perspective of evolution of enterprise networking. The way I think about it is we have had switches, gateways, routers, Ethernet for past 4 decades. I have Wi-Fi for last 2 decades. We think that now private 5G is the third leg of networking that adds and complements where you can do wired networks and Wi-Fi networks, and primarily focusing on like low latency, higher, better coverage type applications. And so a little bit motivating more on why private 5G. On private 5G, you can have much higher transmit powers that can enable wider coverage. Like you can have as low power as 250 milliwatt per port, or you can go as high as 40 watts of power per port. That means you can transmit really high power. Like for example, in some cases we can cover like few hundred acres using one access point. So it makes it much easier from a coverage story perspective. Better MIMO orders, better receiver sensitivity. So 5G generally, you can do minus 110 dBm of receiver sensitivity. So you can have end user devices much farther from the base station. So private 5G in general, like it's really combining two concepts. So 5G, which was a wide area network concept, bringing those technologies and concept to wireless local area network type applications. Also using 5G, we can do deterministic performances. Like for example, you would have licensed spectrum. You'll operate private 5G in a licensed spectrum. Like for us to set up a 5G network here at our booth, we got a special license in N77 band, which is 3.8 to 4 gigahertz band. And so we virtually have no interference because we got a permanent temporary license to operate in that spectrum. And generally, like different countries have different rules. You will get spectrum for this particular venue or a location for a certain amount of time, and you can always renew it. Dedicated quality of service per device, you can configure them, low latency, deterministic latency. And then the third main aspect of private 5G is security. So you could do SIM-based authentication. I know a lot of people stop by our booth trying to scan the QR code, get on our network. So the authentication for 5G is SIM-based versus like username password-based. Also, in case of private 5G, you would have your data go through the enterprise's network. So it's in terms of like contrasting it with public 5G, the network still goes through an enterprise's firewall. So the data stays within their control, and then you could integrate it with identity and services engines to MDMs to manage and configure policies for all the end user devices. We're primarily focused on, or private 5G right now is primarily focused on industrial applications because that's where there's a big ROI. And one motivation I want to drive towards is like a lot of industrial applications have closed loop control. Like for example, a sensor talking to an actuator, and then like for example a gas sensor talking to a valve, right? Today all of these are wired, but with 5G you can have them wireless, and the reason for that is the reason they're wired in first place is because typically 1 second is kind of like a control loop outage limit. Like if you have a packet that goes from the sensor to the access point to the valve, goes beyond a second, it tries to breaks the control loop, and so In case of Wi-Fi, you could get really good latency sometimes, like for example, even a few milliseconds. But you could also go as high as tens of seconds, right? And so for having deterministic latency, 5G in general is much better because you can define a specific quality of service with specific packet error rate, where your latency is capped at 100 millisecond. And both latency as well as jitter are capped, which are both of those things being super important. Use cases in this case, you can see that 5G's latency is though higher than Wi-Fi on an average, is very well deterministic versus Wi-Fi would go all across. This is a architecture for general 5G deployment. So you have radios, indoor radios, outdoor radios. Outdoor radios are, some of them could be lower power, as we talked about, high power going up to 40 watts. And we have a concept in 5G of core network. So Wi-Fi is layer 1, layer 2. 5G goes from layer 1 to layer 5, in some cases layer 6 as well. So the layer 1 to layer 3 will be part of what we call as RAN, radio access network. We also call it access points, like 5G access points. And then layer 4 and above stays in the core network, which we call it as a core network server. Typical public networks, when you say a concept of a base station or a tower, the radio access network would be in the tower. So you will have the radios and the software for layer 2, layer 3 that is running in the RAN network. And then for operators, the core network is in the data center, right? And like, for example, there will be a core network for a whole city or certain parts of the city, and then they will all kind of come together. In case of private 5G, we bring the concept of RAN and core, both of them, to on-prem, onto the enterprise's network. Because it's kind of like a contained network in itself, right? And so the only thing that goes goes to the cloud is the control and the management. So a typical packet from an end user device would go from a phone or a router or a machine, would go from there to the access points. From access points, it would hit our core network. And then from the core network, it would then pass on to the enterprise's existing network infrastructure. And then it will go to the specific router, firewall, and it'll follow the policies that are set for that particular VLAN. And so it's very much like a contained network. And in the next slide, I'll try to kind of motivate the concept of combining enterprise network and the 5G network together. So you can operate. So as I said, the 5G network is layer 1 to layer 6, but you can run it in an L2 networking mode. Similar to how Wi-Fi and wired network works, right? And so if you configure it to run in the L2 networking mode, the enterprise's routers or gateways could assign IP addresses and policies to the end user devices. So for example, you have a forklift in a warehouse that is connected via a 5G network. The enterprise's gateway can assign an IP address to it, set it up in a particular VLAN mode, right, and also have policies for its traffic to hit a particular or segmented particular part of the network, and you can do this across the devices. Also, you could even bridge the network where where two or multiple devices could talk to each other when they are when they are part of the same VLAN. There are protocols like PROFINET that require really low latency and low jitter that have historically not worked on Wi-Fi and would require wired communication, and that's really where legacy industrial wired networks have been supporting. Using the low latency capability of the of 5G, you could run like protocols like PROFINET or over our 5G network. Here's an example of a 5G network deployment for a construction site. Construction sites have no concept of networking because they are a construction site, like we talked about in the previous presentation. This is a use case where our customer is using autonomous driving modules to autonomously or to teleoperate construction vehicles. And in this case, most of these, any teleoperation would require a reliable connectivity and a low latency network. And that's one aspect. The other aspect is it would require heavy uplink because there's a lot of camera feed that is coming from the vehicle onto the operator's screen. And the operator can be there on the site or can be remote, right? And so you could do it using, so there are only two wireless technologies that could make it possible. One's Wi-Fi, the other is 5G. In most of these remote cases or remote areas, public 5G is not available. Public 5G is also not dedicated, so you may have connectivity sometime. If it gets busy, you may lose connectivity. So in this case, they deployed 2 nodes, each node transmitting 10 watts of power to cover like a large construction site, a few hundred acres, and then connect these vehicles to it, and each vehicle doing anywhere from 10 to 20 megabits per second. To give you kind of like the magnitude of how latency is critical for this, if a vehicle is driving at 20 miles per hour, that's 8 meters per second, right? And so if you have even 100 millisecond of jitter, that could be anywhere from 2 to 4 meters, right? And so anytime a frame drops, the vehicle just immediately emergency stops. So for a smooth communication, you need a very, very reliable low latency network. And we've been able to achieve that using 5G. In this case, here's a video example of how they would drive remotely the construction vehicle. Either they would drive it remotely or it will autonomously complete a mission. So as I've been, latency is the critical factor for these applications. Having 99% plus latency, less than 50 millisecond is super critical for all robotics application, and driving quality of service policies on 5G allows us to do that. Another example where private 5G becomes really critical is industrial applications. Industrial applications are always uncarpeted environments and areas where it feels like a Faraday cage, lots of metal, and so propagation of signal is very poor, whether you take 2.4, 5, or 6 gigahertz. So in this example, we covered 20 industrial buildings using 21 nodes. So it's like a 1 node per building, and each building is anywhere from 50,000 square feet to 200,000 square feet. And it just goes to show how deeper or penetrable the coverage is when you use 5G, just because of a better receiver sensitivity, also being able to do higher transmit power. And in these industrial applications, you could also connect forklifts, scanners, tablets, etc. To provide data to them. Before implementing a 5G solution, most of these customers or venues would just use wired communication. If somebody does a Wi-Fi study, that's like, oh, I need 400 access points or 500 access points, and that's just not feasible, especially in environments like these where installation becomes very challenging because you have to be very careful with explosion requirements or corrosive materials are being used, so you can't have a lot of wires there. So I have a 5G network set up at our booth. Some of you folks stopped by to try enrolling your devices on it, try to experience it. As an example for a coverage here, with just one access point, we've been able to cover most of this area, including some coverage inside as well. And feel free to stop by for any question. And thank you for giving me an opportunity to talk about Pride 5G.